All right, now we're going to look a little bit more possibly complex example. So that doesn't look anything like an inverse trig function, but it does have a square root. It has your variable minus your constant. That's not arcsine. It looks kind of like arcsecant. So that tells me I'm going to use the triangle, and I'm going to put it in terms of secant theta. I always have my variable on top of my constant, and I know secant is hypotenuse over adjacent. So let's see, u is going to be y and a is going to be 5. All right, so u over a, hypotenuse over adjacent, and again using my Pythagorean theorem, this is going to be y squared minus 25. So let's look and see what all we have to find. We have to know what dy is, we have to know what y cubed is, and we have to know what that square root is. All right, so I have the secant of theta is y divided by 5. So I need to find the derivative. There's a couple of different ways to do that, but I find the easiest way is to go ahead and multiply both sides by any constants. Now the previous two examples, that constant was a 1, and so that was kind of easy. All right, so now I'm going to take the derivative here, and the derivative of secant, remember, is secant theta tangent theta. Don't forget that d theta. The derivative of y is dy. Okay, so that tells me what dy is. Hey, that also tells me what y is. So I have y and dy. The only other thing I need to know is what that square root. So again, this is where I go to my triangle. I need that square root side. Then I pick the other side that doesn't have the variable. And I go, okay, what trig function involves opposite and adjacent? You got it, tangent. So the tangent of theta per my triangle is opposite over adjacent. And since I need the square root by itself, I'm going to multiply both sides by 5. So I'm just filling in at this point. Okay, so I need to know what dy is, all of that. I need to know what y cubed is, so I know what y is. I'm just going to have to cube it, and then I need to know what that square root is, and I have that. Okay, so the square root is 5 tangent theta. Dy is 5 secant theta tangent theta d theta on top of y cubed. So y is 5 secant theta, and I need to cube that. Now I know that looks ugly, but let's just hold on. I think we can simplify quite a few things. Okay, so hopefully you see that 5 times 5 over 5 cubed. Right? So 5 times 5 is 5 squared divided by 5 cubed. That is going to leave a 5 in the denominator. So I've kind of taken care of that. Then I have tangent times tangent. That's not going to reduce or anything, so that's tangent squared. Then I have secant over secant cubed. Secant over secant cubed is going to leave a secant squared in the denominator. Well, what's that? I don't know how to take the derivative. I don't know how to take the integral of that. Use substitution doesn't work. But maybe I can change it into stuff that I do know. Okay, so I'm going to go back to my trigonometry and say, what is tangent? Tangent is, yes, opposite over adjacent, but it's also sine theta over cosine theta, and it's squared. Okay. Secant squared theta, well, first of all, what happens if I put it in the numerator? What does it become? It becomes cosine squared theta. Well, this is great news. So now I can reduce that out, and I have 1/5 times sine squared theta d theta. This should be something I know how to integrate. So again, I have to use my identity for sine squared. So that is 1 minus cosine 2 theta over 2. So 1/10 of 1 minus cosine 2 theta. So that's going to be 1/10 theta minus 1/20, because of the 10 and the 2, minus 1/20 sine of 2 theta plus c. So just like on the last example, I have to figure out what theta is, and I also have to make that substitution of 2 theta. So what is theta? Again, you can have lots of choices, but I think I am going to go to here, all right? Or actually, I'm going to go up one line. I'm just going to take secant. So theta is going to be inverse secant of y over 5. You could have also said inverse tangent of that. Again, lots of things. Okay, and remember that the sine of 2 theta is 2 cosine theta sine theta, and I'm going to make that substitution there. Okay, so I have 1/10 theta minus 1/20 times 2, so that goes back to 1/10, of the cosine of theta times the sine of theta plus c. Cosine theta, is that anywhere on our paper? Let's see, I'm looking, no, I don't, where's the cosine of theta? Go back to your triangle. What is the cosine of theta? Back to the triangle. It's adjacent over hypotenuse. So the cosine of theta is 5 over y. What's the sine of theta? Is that anywhere on my paper? No, but it is on my triangle. It's opposite over hypotenuse. So it's the square root of y squared minus 25 divided by y. And yes, you could clean that up quite a bit. All right, I will leave that to you, but you could reduce here and you could combine those. But that's about it. Look at this problem. Which triangle are you going to use? Sine, tangent, secant. Now you can use the other trig functions. Those are just the easier ones to use. Okay, so we look at and say, hey, I have a square root. It's in the form of my constant squared minus my variable squared. Constant minus variable, that should tell you use sine. Okay, so the sine of theta is going to be u over a. So a is 4, u is x. So I would have x over 4, and then this is going to be 16 minus x squared. So the sine of theta is opposite over hypotenuse. It's always easier if you do your trig function in terms of where your variable is in the numerator. Okay, I'm going to multiply both sides by 4 because I know I have to find dx, and I also have to know what x is. So now I know what x is. The derivative, got that. And then the only other thing I need is the square root. So I go to my triangle, I choose that side, and the side without the variable, and I go, okay, I could use secant or I could use cosine. I think cosine is the better route. So that would be adjacent over hypotenuse, and since I need the square root by itself, I'll multiply both sides by 4. Okay, so again, let's play the matching game. All right, what's dx? What is x? What is the square root? So the only thing I don't have is what is 4. It's just a constant, so I'm just going to pull it out anyway. Okay, so I'm going to take that 4, put it outside the integral sign. So 4 times the integral of dx, so I have 4 cosine theta d theta. In the bottom, leave it in the bottom. What is x? It's 4 sine theta, and I'm going to have to square it because it's x squared. Then what's my square root? 4 cosine theta. Ooh, look at all those 4s. Do all of them cancel out? Let's count. So remember, this is over 1. So I have 4 times 4, which is 4 squared. So they all go but that one. So I'm going to put that 4 in the denominator. What else can I reduce out? Well, cosine over cosine goes. So that just leaves me d theta on top. And then all I've got left on the bottom is sine theta, and it is still squared. What's that? Well, what's the reciprocal of sine? Cosecant. Should I know how to integrate cosecant squared? Yes, I should. It is on one of my lists of my basic integrals, and it is negative cotangent theta. Oops, not cosine, cotangent theta. Cotangent theta. So I have to go find out what the heck cotangent is. I see that nowhere on my paper, but I can go to my triangle, right? Remember, cotangent of theta is defined to be adjacent over opposite. So adjacent over opposite. So that's going to be negative 1/4 adjacent over opposite. Not so bad.